In this video, I'm going to go over the answers of your Unit 6 pretest or practice test for solving systems of equations. Your guys' actual test will look very similar to the test here in front of you. Okay, same setup. I'm just going to change the equations, of course, so that you're not solving the same problems. All right, your first question on the test will be solve the system by graphing. You need to graph the two equations and find their intersection point. When you graph an equation, you're looking at the slope and the y-intercept, and you're using those to plot your points. First equation is 1/2 x minus 4. So my y-intercept is -4. So I'm going to go down to -4, plot a point, and then I'm going to use the slope of 1/2. And I'm going to go across the graph. And then I can reverse some points as well. That should be enough, but remember, if you're trying to find that intersection point, you want to be as precise as possible. So go ahead and extend across the graph, okay? The other equation is y equals -x plus 2. I'm going to start at +2 since that's my y-intercept. And then I'm going to use a slope of -1. Remember, if you have a whole number, in this case we have -1, all whole numbers are over 1. Down 1 over 1. Down 1 over 1. Okay, I found the intersection point. It's right here. The intersection point is 1, 2, 3, 4, 1, 2. So it looks like it's 4, -2. Right here it says to explain. As long as you show your work over here on the side, like on the graph, then that's okay. I can do this. I could say for my top equation, my slope was 1/2, and my y-intercept was -4. And then for my bottom equation, my slope was -1, and my y-intercept was 2. That would help explain what you're doing. But like I said, as long as you graph and show your work, then you're good. Okay, so 4, -2. If you wanted to check, you could plug the point in just to make sure that it does work. We're going to keep going to try to make this in 2 videos. Number 2, solve the system of equations using substitution. All right, so for substitution, we're going to take one expression for a variable and plug it into the other equation. So I'm going to take this 3x minus 4 and I'm going to plug it in for the y in the other equation. Okay, I'm going to write this out. -15x plus 5. Okay, so now I've got my y. Always plug it in with a parenthesis. 3x minus 4. And then keep writing. Equals 10. Let's solve this for x. Start by distributing. -15x plus 5 times 3x would be 15x. 5 times -4 is -20 equals 10. Combine like terms. And when I do that, the x's actually eliminate here. So the x's are gone, and we have -20 equals 10. So this is a situation that we learned last week. Whenever everything eliminates out, or all the variables eliminate, you ask yourself if it's a true or false statement. Does -20 equal 10? No. This is a false statement. False statement means no solution. These two lines are actually parallel. Okay, so just be cautious if that happens on the test. That's how we do it, just like we learned last week. Okay, number 3, solve by elimination. In order to eliminate, I want to make sure that one of my terms is going to eliminate when I add down. If I add down right now, the x's do not eliminate. If I add down on the y's, they do not eliminate as well. So I'm going to have to multiply by something. I'm going to multiply the bottom equation by a 2, and that'll turn this into a -4x, and these will eliminate. So I'm going to start by rewriting. Okay, and then I multiply the bottom one by a 2. This becomes negative 4x minus 10y equals negative 2. All right, now I'm ready to add down. When I add down, my x's eliminate. 3y and negative 10y is equal to negative 7y. Timeout. This is a positive 10, not a negative. I multiplied by 2, that should stay positive. All right, 3y plus 10y is 13y. 15 minus 2 is 13. There we go. Divide by 13 from both sides, and we get y is equal to 1. Let's take this 1 and plug it in. I'm going to plug it into the top equation. So I'm going to take this 1 and go right here with it. 4x plus 3 times 1 equals 15. 4x plus 3 equals 15. Subtract 3 from both sides. 4x equals 12. Divide by 4. X equals 3. So the answer to this system, and make sure that you finish it up like this. You put 3, 1. You need to write your answer as an ordered pair. Okay? That's the last step. Don't forget that part. All right. The next set of questions, you're identifying what types of solutions that these have. Okay? The first system, I noticed that they have the same slope but different y-intercepts. If we were to graph these would be parallel, right? Parallel lines have no solution. So how did I tell? I compared the slopes. If the slopes are the same but you have different y-intercepts, that's going to be a no solution problem. All right, you can only do that when they're in slope-intercept form, and both of these were. The next system is not in slope-intercept form. So this one we might have to rearrange. Okay, I'm going to start by, so I see that the coefficient of this x is just a 1. So I'm going to look at this bottom equation and see if I can turn the coefficient of that x into a 1. So I could divide by 4 and turn it into a 1. All right, so what is the bottom equation going to turn into after I divide it by 4? Okay, it would become an x minus 4y equals negative 4. Then I'm going to see if I can rearrange them so that they're the same. Okay, so I'm going to move this 4y to the other side just like the other equation has it. So if I move it across the equal sign, I would have to add it, right? And I get x equals 4y minus 4. Those are different terms, so they stay separate. These two, I've rearranged them to where they actually line up to be the same, right? So these are just the same equations. And remember, you don't have to do it this way. Like you could rearrange it and solve for y if you wanted to, like we did in the first group. These were solved for y. You could multiply the top by a 4 and try to line it up to use elimination. Okay, so you have different options there, but you're gonna have to rearrange it. All right. So these are the same equations. If it's the same equation, it's infinitely many solutions. Infinitely many. They're always crossing. Next system. Those are in slope-intercept form. Let's compare their slopes. The slope of the first one would be 1. The slope of the bottom one is negative 2. Those slopes are different. So these lines, if I was to graph them with different slopes, eventually they're going to cross somewhere. So this is a one solution problem. I don't actually have to find the solution. I'm just identifying how many solutions that it has, right? So no solution, infinitely many, one solution. The last system, Now look at the last system. We could use elimination to figure out, like, am I going to get an answer? Am I going to get a no solution? So I'm going to use elimination, and I'm going to subtract the bottom. Okay, so if I subtract the bottom, I'm really switching the signs. And what happens is when I add down, these eliminate, giving me 0 is equal to 15 plus 1, so 16. And if we condense it down, or if we solve it down and we get a false statement like here, 0 does not equal 16, false statement indicates this is a no solution problem. Therefore, those lines are parallel lines. Okay, so another no solution. All right, so quick recap on what you can be doing for a question like number 4. Number 1, compare their slopes. If they're in slope-intercept form, if they have the same slope, you know they're parallel, unless they're the same line, but most of the time it's going to be parallel. If they have different slopes, then they're going to be crossing. Number 2, you can rearrange things. Rearrange and see if they line up to be the same equation. I rearranged that second one for x. Most of the time we probably rearrange and solve it for y, or we rearrange and set it up for an elimination problem. But that's the other strategy, rearrange. And then number 3 is try to solve it. So you could use elimination, or you could use substitution and try to solve it. And if you get to where it's a no solution problem, you're going to have a false statement. If you were to get a true statement, it would be infinitely many. If you actually get a point, then that means one solution. All right, so those are your strategies for identifying what types they are. All right, we're going to stop this video here. I strongly recommend going through the practice test before watching these videos. So hopefully you're trying them first and then going here to check your answers. Thanks for watching. If you have any other questions, let me know.